Hello everyone, welcome back to the stream. Today we're going to continue with the Vulkan tutorial and try to put a texture on the screen. So if you remember from last time, we managed to load an image and using STB image, the STB image library, we got the pixel image as well as the width and height of the image. And we created a Vulkan image object where we later transferred the pixels through the use of a staging buffer. So today we're gonna see that we need to create image views to actually access the images, and later we'll see how do we create a sampler in order to be able to access this texture from the shaders. So let's start by creating the actual image views. Let me see here. We're gonna want to call bk create image view somewhere after we create. Let me open the project. So last time we were creating this function, create a texture image, yeah. So right after that we can create our texture image view. And then we need to call this function, passing in all the necessary information. So now we need to fill in this image view create info with the usual structure parameters, structure type, image view create info. Let me actually grab the image view create info. We need all of those. And let's see. Phoenix is always null for us. For the flags, we can set 0. This is gonna be the image that we created last time. The view type is gonna be 2D image, and the format is the format that we are using during all this time. Then we need components. I don't see it here. So what is this component mapping thing? This is a struct with our, I think we can set all to 0. bk component mapping. bk component mapping. Text bk component swizzle. And the swizzle identity is 0, so yeah. That would work for us. And then we also need the sub-resource range, which consists of, can we not use 0 here? Okay, component swizzle identity then. This is basically shorthand for, well, equivalent of using zeros. For the sub-resource range, what do we need? PK image sub-resource range. We need all of those. Paste it in. Oops. The aspect mask. I think it's gonna be BK aspect, image aspect, color. Base mid level is gonna be 0, 1 level. Basically, we already specified all of these for the texture image, and I expect this to be the same. If we look now here, yeah. Here they left out the components because Swizzle is 0, but we cannot do that in Rust. We could implement a default for VK component mapping to be always initialized to 0, but I'm gonna add this as a comment or as a to-do. Implement default for VK component mapping, and that would simplify this initialization. So now we are creating these image views. We should free them somewhere. In the cleanup, here we're cleaning up the image, and we also need to destroy the image view. Texture image view. What next? Here they suggest to extract the logic into a function, create image views. Create image view. Because we have pretty much the same functionality when we create the image views for the swap chain, right? So we have duplicated code now, and we could reuse it both for create images, image views, and create texture image view. So let's add this function, create image view, and we're gonna return a BK image view. And all of this code that we just typed before, create image view, all of these, you can grab it and delete it and basically put it inside here. I'm gonna rename this to just image view to be more generic. gonna take the image view, and we will later return this image view. Now we just need to fix all the compiler errors. So we're gonna need the device, the image we want to create the image view for, and we could maybe pass the view type, the format, and all of this could be parameterized as well, but I don't know. This is not auto formatting for me. I might have a mistake in here. I'll check. So we needed the device and the text, the image. And now this create image views functionality can basically use create image view, passing in the device and the image, which in this case is swap chain images at I, and store the result of this inside of the swap chain image views. We can now get rid of this. We get a few errors. Line 700. 700. Okay, I missed here. Anything else? Okay, now everything is just warnings. So let me see what's next. Okay, let's set running, because the next step is already to work on the sampler, but we get a bunch of problems. Formats must be identical. Where? Format. So let me see the diff. This is the function call we introduced. And here we were using bk format. View type 2D. Isn't this the same format we use in create image view? Format is bk format. No, it's not the same. They pass one for they pass the swap chain image format for one. I see. So basically in here we want to have a third parameter, which is the BK format, and use that. It should compile now, but everywhere where we use this create image view, we now should specify the format. So this one should be the swap chain image format, which is this one. Like this, and where we create the image views for the texture, we want to specify this very specific one, RGB8. So let's see if now we get any better result. I thought I was passing in the this one should be also this format, I think. So we are calling create image view in a lot of places. This is the function. We call it inside here where we create the swap chain image views. Then we also have it here for the texture, and okay, where we recreate the swap chain. So this code is a little bit duplicated. I'm done. Format is not at this level. Okay, back to working. Let's now move on to samplers. Samplers are basically used by shaders to be able to read the textures. And in samplers we can specify filters and so on. So we can choose to not have any filter or use bilinear, for instance. We can have anisotropic filtering. So let's see how do we deal with this. So we're just gonna create this create texture sampler function and fill all of these structures. We need to get the physical device properties to check if anisotropy filtering is enabled. Right, to get the maximum sampler anisotropy. And then we fill all of this stuff. So let's start from the bottom, try to create the sampler. So we can go here and add this call for create sampler. text of device, sampler information, I don't know the name exactly, and we're gonna name the sampler just texture sampler. And now I need to go ahead and look up this function definition. I can open the Vulkan core header and just search for it. Sampler, and copy it over to our bindings in here. Create sampler, text in the device, and this big structure with all the parameters, the creation parameters. Create info, so we are gonna have to define this create info. Maybe right after image view create info. Makes sense to create it there. What are you saying? Image view, create info in here. It takes all of these things, so I better copy this. But I need to copy to the clipboard. Oops. One more time. And now paste it. I'm gonna try to record a macro for this. How many? So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. So 20. Let's start recording. Delete, up, base, word, B, up until here, delete, go to the end, space, paste, bang, and stop recording. So more or less the macro worked. Now I just need to fix some minor things. This needs to be C-void, and then all the floats needs to be F32s. Okay. So what now? We need to add in this sampler, create flags, filter, and a few more other stuff. So let's go by one. Ooh. That's one. Now we need this decay filter. Probably just an enumeration. Yeah. Filter, border color, logic up. Do we have it in here? No. Stencil? No. So let's grab border color and filter at the same time. Sampler address mode, we also need it. Sampler mipmap mode as well. And that's it. How do I copy from one register to another? Copy. I want to copy from this register into the plus register. So let plus equals does this work? I don't think so. Okay, one more try. Copy from the plus register. No, yeah, from the Okay, I think somewhere it worked. So we can go here to the last enumeration that we have and paste from the. Okay, I think that worked. Now we just need to adapt it to Rust. I think we're still gonna miss a few. Almost there. Sampler. Last one. So we have all of these defined. We are just missing BK compare op. And now we just get a few complaints because we cannot have more than one variant for the same number. The same here. And now probably we'll get errors in main because we are not using yet. So, okay, filter create info or BK create sampler. So this should be sampler create info and have all of these fields. The structure type is a simple one. Type sampler create info. The next is also easy. For the flags, maybe we don't need them. Let's see, where do we start creating sampler info? I don't see anywhere using filters, flags, sorry. Mac filter is gonna be linear. And the same for the min filter. The mid-map mode is gonna be 0 maybe? No. Linear as well. The address mode U. It's gonna be a repeat for the 3 coordinates. So repeat. The bias was 1 or 0. Load bias. Cannot see it. 0. All the floating points are 0. Anisotropy enable. We need to check if we have support for it, but they are setting it to true. Most graphics cards have support for this. So. Then max anisotropy. It's what it says that we need to get it from the We could be fancy and do it in a block. Maybe, I think it should be doable. We get this, and then we return properties dot limits, basically this. And since Rust evaluates the last expression of a block as the returning thing, we just need to use the physical device here. And I think it should be good to go. Looks like it is. Then compare enable false and compare up. This compare always. These two were 0. Border color shouldn't matter because we repeat. So black. And unnormalized coordinates, true or false? False. Let's see if the compiler likes us. And turns out that this worked. So it would be nice to cache the physical device properties somewhere because we might need them later on. And we are only evaluating them inside the for loop where we iterate over the physical devices right now. So we create the sampler and we also need to destroy it. Let's view. And we don't have a definition for this yet. So let's go ahead and add it. That should be all that we need. So we can try to run it now. And the tutorial mentions that we might get a validation error because we need to check before using anisotropic sampling. And that is exactly what we are getting here. If the anisotropic sampling feature is not enabled, anisotropy enable must be false. So we need to enable this feature if it is available for us. So when we create the device, create device, not in here, but in our main. We specify the queue, create information, enabled extensions, enabled features. Here we're using just features default. But we could enable specific features, right? We could tell it to use sampler anisotropy. So what if we instead do pk physical device features, and then if the syntax is the syntax like this, And then I don't remember if it needs to be the first or the last. Sampler anisotropy. I need to look this up. Rust, I think it's called struct shorthand syntax. So we can specify every single field, or, well, we can specify the fields with the same name, or we can do that. That's what I wanted. So it's the other way around. I specify first this, and then 2 dots, like so. The base struct must always be the last field. It's because of the comma. I think that works. It compiles at least. So we are using the feature willy-nilly. So to do check that this feature is actually supported, and we're not gonna do that because I think if I go to PK, is it Vulkan info? Yeah. And I grab for anisotropy, maybe. What is sampler anisotropy? Exactly. So yeah, we can see that the 2 GPUs that I have on this laptop, both of them actually support anisotropy, so we should be fine. But in other people laptops, this might not, in other people machine, this might not work. So that's why I added that to do. If I now run this, we don't get any error anymore. Quitting also doesn't trigger any validation, so that's good. We can skip all of this. If we don't want to force the availability of anisotropic filtering, it's also possible to not use it by setting anisotropy enabled to false and maximum anisotropy to 1. Okay. Let's move on to next chapter. We looked at descriptors for the first time in the uniform buffers part of the tutorial. In this chapter, we will look at a new type of descriptor, combined image sampler. This descriptor makes it possible for shaders to access an image resource through a sampler object like the one we created in the previous chapter. I see. So we need to modify the descriptor layout, descriptor pool, and descriptor set to include this combined image sampler descriptor. And after that, we need to add texture coordinates to our vertex structure and modify the fragment shader to read colors from the texture instead of just interpolating. Okay, so where do we have our set layout? Create info. It's in here. And we're using one descriptor set layout binding directly. But now we want to have 2, right? So we'll have 2. The first one is gonna stay uniform 1, but the second one is gonna be this sampler combined image sampler thing. So down here we can no longer use a reference. We're gonna need to update this to an array and then do a pointer. And that allows us to add a second one here with all of the same fields. Binding is gonna be 1, I suspect. Descriptor count is 1, but the type is gonna be combined image sampler. And probably we want to do this on the fragment bit. Yeah, and we also don't need immutable samplers. And then the count, we already updated it to 2. So that's all we need in this part. What we need to change next is when we create the descriptor pool. We also need to have two descriptor pool sizes, I think, no? Yeah, we're gonna have 2, one for the uniform and one for the image sampler. So change this to 2. This is gonna be now an array and a pointer. Okay, descriptor pool size. The type is this, and the descriptor count I think is also gonna be max frames in flight. Yep. So we got also that one updated. The 2, that's right. And last thing is when we go ahead and create the descriptor sets. And we do, no, when we update. Yeah, when we bind, that was for creation of the pool. The final step is to bind the actual image and sampler resources to the descriptors in the descriptor set. Go to the create descriptor sets. So basically where we call update descriptor sets. Here. We have a write descriptor set, which has one buffer info. But now we are gonna have a descriptor writes is gonna be an array of 2 elements. Getting confused now. So we have this array of 2 elements in line directly in here. But the point is that we need to change this to 2 and convert this to an array. And a pointer here. Then I'm just gonna copy all of this. And modify it as needed. For this second one, the type is the same, the descriptor set is the same. The destination binding changes from 0 to 1. The array element is still 0. We need to change the descriptor type and add this image info. So instead of using the buffer info, we add a new structure in here, bk descriptor image info, and fill it in. And this one, oops, this one we can replace it to be basically no. Now we just need to add all we need in here. Okay, descriptor image info. So just the sampler, image view, and image layout. The sampler is gonna be texture sampler. The image view is gonna be texture image view. And the image layout is the one I don't have. Okay, image layout, shader, read, only, optimal. Save that. And see if that compiles. It does. So now what is next? We need to update our vertices. So, but what happens if I run this now? I don't get any errors, which is interesting. Vertex. So here we have our position, color, and we can now add in the text coordinates, maybe UV. So with that, we will have, instead of 20, it's gonna be 28, right? 28 bytes in total. And we can update the get binding description. Get binding description uses the size of self. So it should be still working, but the get attributes, we should add a new one for the texture coordinates. So down here, copy one of those, paste it. Location is gonna be 2, and this one is just R and G. And the offset, basically is gonna be 20 bytes. So the size of these 2 floats plus the size of these 3 floats So I'm just gonna do size of one float. Times how many floats we have before us, which is 5. 3 for the position, 2 for the position, and 3 for the color. And we need to change this one to 3. And I think that should be okay. And now we just need to update everywhere where we use vertices. Ooh. Such as here. We need to fill them in. So 1, 0. The second one is 0, 0. Third one is gonna be 0, 1. And the last but not least is gonna be 1, 1. That should get us back to compiling state, or maybe not. Expected 61. Expected an array of 2 elements, found one with 3. Did I not change that? Thought I changed that. Maybe not. Okay, back to compiling. Now we need to update our shaders. Cool. So let's start by modifying our vertex shader. Shader vert. We are gonna need a new input attribute for the UV coordinates. Location 2, as we specified. It's a vec2 in UV, in text core. What are they using in here? Text core. And I think we just pass it straight away to the fragment shader, because that's where we want to sample our textures. So we pass it at location 1, frag text core, and then we just assign it here in text core. That should be more or less what they are doing here, right? Yeah. Yeah. And then we can update our fragment shader as well, adding the new input attribute. And the first thing that they do is just output this fragment texture coordinate as the R and G color components, and then we should see this kind of, where the coordinates are 0, 0, the texture coordinates, we should see green. Wait a second. 0, 0, red, green. No. Shouldn't it be white? Sorry, black. I'm a bit confused. 0, 0, and 0. That should be white. I don't know. Obviously, there's something I'm not getting. So instead of using frag color, we can use frag text color. And if we now compile the shaders again, constructor, not enough, data provided. That's because we need a 0 here. This is a vector 2, but we had a vector 3 before. Now it compiles. And if we run this now, we see something similar to what they are having, right? Yeah, I think it's mostly what they have. I want to get though why. So our UVs are 1 0 0 0. Is it 0? Did they set 0 0 at some point? 0 0. Yeah. One of the vertices should be at 0 0. 0 1 1 1. And then in our shader, maybe that vertex is black. But since it interpolates to green, we don't really notice it. That could be. That could be. Okay, we managed to see this image here. And now we want to add in this sampler. The green represents the horizontal coordinate, and the red, the vertical. The black and yellow corners. So this is the black coordinate. Green is 0, red is 0, so it's black. And where red and green are full, we get yellow. Yeah. And this is fully green and 0 red. I want to remove the rotation. It's troubling me. So let's just comment this out. I'm concerned about this. I think I have some kind of bug because this should interpolate smoothly from full red to black. So it's possible that I have so red color. Oh. Let me compare this carefully. So -0, -0.5, -0.5, 1 0 0, 1 0. 0.5 -0.5, 0 1 0, 0 0. 0.5, 0.5, 0 0 1, 0 1, -0, 1 1 1, 1 1. So why then are we seeing this Could it be some kind of alignment issue? Just so the size of our vertex is 28 bytes, which is more or less what we expect, no? 8 plus 12 is 20, plus 8 is 28. I think 2, 3, 4, 5. This one, I had this 5 in here. Where did it go? Where did this 5 go? Now you can see that was the issue. Now we can see that we perfectly interpolate from red to yellow, and this is the black. So that was the issue here. Now we're gonna try to use the texture with the sampler. So we can add the sampler uniform in the fragment shader. Up here. And how do we sample? We just do texture, text sampler. Alt color is equals to texture, frag text color, sorry, text sampler. Using the texture coordinates. We can comment this out. Compile again the shaders. Cargo run this bad boy, and there we go. We have the image here. We're getting a bunch of validation issues. At least I got them. I think I got them when I resized the window. Descriptor in binding, but has never been updated. Okay. Update descriptor sets. So we update the descriptor sets once. But the descriptor, or more than once. We actually update them twice. So copy this. So that's the problem with duplicated code. Texture sampler, but those are not available in here. And we also need to where we allocate the descriptor pool, we also need to so I'm gonna undo this change, not this one. So yeah, basically we need to fix the swap chain recreation, but if we don't resize the windows, it seems to be working. I'm just gonna add a big to do. Maybe in recreate swap chain. Update texture sound descriptor set as well. That should cover it. So we can also, since we are using repeat, we could also multiply by 2 the fragment, the texture coordinates. And we can also mix it with the fragment color. So if I go fragment shader and I multiply this by 2, we should see a similar result. We now have the texture duplicated over 4 times. And furthermore, we can, what do they use for mixing? Do they use, they just multiply the frag color times the texture. I see. So back 4. Dot RGB and 1 for alpha. And we can see a similar effect where we have green, blue, blue, and white mixed up with the texture. So yeah, the only thing pending is to fix the swap chain recreation. Let me commit this so far. I'm gonna undo this. Just want the texture. What did we change? The 2 shaders. We added the UV component to the vertex. Can get rid of the print line, this one. We enabled the sampler anisotropy at the creation of the device. When we create the descriptor set layout, this one we created once. So here we updated to use 2 bindings, one for the uniform buffer and one for the combined image sampler. Then we created the texture image and the texture sampler. Do this need to be recreated when we recreate the... They just take the device and the texture image. The swap chain. The command pool does not need to be recreated. Am I right? No. Cool. So the texture image view and the texture sampler don't need to be recreated. But then when we update the descriptor sets, for updating the descriptor sets, we need them. Where do they... Let me check their source code. Where do they... Okay, come on. What? Update descriptor sets. Where do they do it just in one place? In create descriptor sets. And they call create descriptor sets in init Vulkan. So why are we doing it twice? bk update descriptor sets. Why are we doing this twice? Shouldn't it be okay to do it only once? Descriptor sets. What happens if I comment this out? What happens in it? When I run this? So at startup, nothing happens, and if I resize the window, descriptor in binding 0, index 0 is being used in draw but has never been updated. Create descriptor pool. Why do we need to recreate the descriptor pool? So why do we need all of this? Do we need it? Let's see. So startup, it works fine. If we resize, it still works fine. And if I resize manually like this. Okay, so we were just doing stupid stuff in here. We can get rid of this. So it was actually easier to and then we don't need the uniform buffers in here. So where do they have recreate swap chain? That's right, we don't need to do anything about uniform buffers, so we can get rid of them completely. Swap chain. The next ones as well. Okay, so we managed to clean this up and should be still working fine. Okay, I need to recompile the shaders. And I also don't want this repetition. So that's better. Can even go full screen. Yeah. Looking good. So now we are ready to commit. Check one last time. Changes. So what did we do? Want to add everything except the texture folders. So add shader and add source. Create texture sampler, update shaders, what else did we do? We also created this new combined image sampler, right? Update shaders and descriptor sets. That should be close enough to what we did. So now I don't know if we should continue, because the next thing that we have already is depth buffering, and I've been streaming for 1 hour and a half, so I don't know. Let's take a quick look. And after that, we have loading models. Yeah, so that would be cool. So yeah, let's try to continue with depth buffering, because the geometry we've worked so far is projected into 3D, but it's still completely flat. In this chapter, we're gonna add a Z coordinate to prepare for 3D meshes. We'll use this third coordinate to place a square over the current square to see a problem that arises when geometry is not sorted by depth. Change the vertex struct to use a 3D position for the position, and update the format in the corresponding. Okay. So we can do that easily. So we're gonna add here a third coordinate, and then this is no longer true. Now it's going to be 12 plus 12 plus 8, so 24 plus 8, it's 32. And we need to update this to be RGB32. This is gonna be 3 times the size of the block. And this one is gonna be 3 plus 3. So to be explicit, 3 plus 3. And besides that, we need to modify something else. No. Oh, right, the shader. The shader and the definition of these vertices. So in the shader, we just modify to a vector 3. This becomes 3. And then we don't need this 0 that we were having in here. And when we declare our vertices, what are we gonna use for the z coordinate? All zeros, okay? 0 in here, 0, 0, and 0. Okay. Anything else we need? Lastly, update vertices to include a z coordinate. If you run your application, they should see exactly the same result as before. Let's double check that. That's definitely not true, so I made a mistake somewhere. I think the format somewhere RGB32, B32. So pipeline. Alignment for vertex attribute 2. For vertex attribute 2, 0, 1, and 2. What can it be? We change the first one, position, color. Do we hard code somewhere when we create our create buffer, create vertex buffer, we pass in the vertices, and to get the size, we just get the size of the first one times the amount of vertices. So that looks fine to me. Alignment for vertex attribute 2. Do we need to add padding? Do we need to add padding? Shouldn't have removed that. Before. Size is 32. What about the BK create graphics pipeline and the pipeline layout? Pipeline layout, descriptor set. So here we define the stages and the vertex input state, which uses the methods from the vertex. So that should be fine. That looks okay to me. So, I don't know what are we doing wrong, honestly. Invalid attrib address alignment. Attrib address alignment. I remember they mentioned something about alignment in maybe in the input description. Or in the index buffer. Not here. Input description. I remember seeing that. Where was it? Was it in the uniform buffers? I don't remember. What if I just Google for this validation error? Maybe I will get more insights. Or I have the file downloaded, which will be faster. The Vulkan spec downloads, Vulkan spec. It's in here. For a given vertex buffer binding, any attribute data fetch must be entirely contained within the as described in vertex input description. Let's read a bit more about this. Application specify vertex. This is an array of binding descriptions. Attribute description is the number of vertex attribute provided. For every binding specified by each element of P. Here, the attribute description. Location is the shader input location number for this attribute. And binding is the binding number which this attribute takes its data from. Let's double check the binding 0, location 1, location 2. What about the offset? Is a byte offset of this attribute relative to the start of an element in the vertex input binding. Byte offset of this attribute relative to the start. Layout. Doesn't say much. So offset 0. They save, right? Oh, fuck me. I'm just dumb. Of course, multiplication takes precedence over addition. So I was doing 3 times 4, which is 12, plus 3, which is 16, instead of, so it was taking 16 instead of 6 by 4, which is 24. Just for wanting to have this more clear. Dumb mistakes, dumb mistakes. Cool, so now we have 3D positions. We can go back to the depth chapter. We did all of these. And we can now add a second rectangle, which is basically the same, but it's the same but using a z of 0.5, right? So I'm gonna comment this out now and copy the vertices. 0.5 or minus 0.5? Minus 0.5. Minus 0.5. And for the indices, we can add a second line with 4, 5, 6, 6, 7, 4. And now we should see two rectangles, right? I'm not using the same transformation matrices as they do, so we're not gonna see, yeah. So if I go to the source code, they are using lookup matrix. For the view and the projection, they are using this very specific transformations. But we are not using GLM, so I was in the process of adding so I added the rotation functionality, but we're still missing this look at and perspective. I could hard code these matrices, but I rather not. I have to. I added to-dos for this look at and perspective, but I need to study a little bit more the math to set this up. But I will do that next time. And I think I will also close the stream here. And we can continue next time. So thank you all for watching, and I will see you next time. Peace.